Turner, and I'm an electrical engineering major.
I'm Sophia Demers, and I'm also an electrical engineering major.
I'm Christine Hawkins, and I'm a computer engineering major.
And I'm Simeon Feliz, and I'm a computer engineering major.
Together, we are the creators of the Nightwing AI Transcribe.
We set out to solve the communication gap in mission-critical environments where internet access is not available.
Our device translates and transcribes real-time radio transmissions like walkie-talkies and sends the data over Bluetooth to an Android mobile device.
By combining real-time AI translation, a custom power-managed PCB, and software-defined radio, our system creates a portable and offline system for translating and transcribing in the field.
But to understand why we built it, imagine this. You're a spy on a mission in a foreign country, tasked with infiltrating a high-security building undetected. The challenge? Enemy forces are using portable radios to coordinate patrols and potential lockdowns. With the Nightwing AI Transcribe, you can intercept their communications in real time, capturing, translating, and transcribing their conversations. This critical intel allows you to navigate the area covertly, staying one step ahead. That's why we built Nightwing AI Transcribe, a fully portable, secure translation and transcription system that works anywhere.
By keeping all processing on the Jetson Orin Nano, our system runs offline, protects privacy, and performs real-time confidence evaluation, all without a cloud connection. Sponsored by cybersecurity leader Nightwing, our project is now part of their client-facing demos, showcasing secure edge computing for the future of communications. Systems like this can support real-time communication in high-risk environments, from military operations to disaster response, where internet access isn't available and translation can be mission-critical.
So how does the Nightwing AI Transcribe actually work? Let's take a closer look.
Introducing Nightwing AI Transcribe, a portable and discrete system designed to transcribe and translate walkie-talkie communications in real time, all without needing Wi-Fi. Here you can see the two main parts of the system: the backpack, which houses all the core hardware, and the handheld device, which displays the transcribed audio. The device connects via Bluetooth, allowing users to view live transcription seamlessly. Inside the backpack, we have a custom 3D printed enclosure that securely holds all the components. The enclosure is designed to keep everything compact while routing the antenna discreetly to the top for optimal signal reception. This is the base of our enclosure, which serves as the foundation for our system. It is structured to fit all the components in a stable and organized manner while ensuring ventilation for heat dissipation. Mounted on top of the enclosure is a touchscreen display that serves as the main interface for the ESP32. It allows the user to start and stop the transcription process, initializes the Bluetooth connection with the handheld device, and provides real-time system insights. On the first shelf of the enclosure are the custom PCBs, including the ESP32 development board, a current sensor board, and a 5V to 3.3V regulator board. These handle power distribution, communication, and data transmission. On the bottom shelf of the enclosure is the Jetson Orin Nano, the core of the system. It processes incoming audio from the walkie-talkie and runs the Whisper AI model for real-time translation and transcription. Also on the bottom shelf is the add-on Pluto SDR, a software-defined radio that captures the specific frequency of the walkie-talkie and demodulates it into an audio data for transcription. As previously mentioned, the SDR's antenna is discreetly routed to the top of the backpack to ensure optimal signal reception. And here is the battery stored on the side of the enclosure. The Cristonia power bank provides enough power to keep the entire system running for approximately 6 hours. Here we see all the components integrated inside the enclosure, ready to be placed inside the backpack. The final piece of our system is our handheld device, which connects to the backpack via Bluetooth. The mobile app allows users to start transcribing, view live text, and manage the system remotely, making it a seamless experience.
You've already seen what the system looks like and how it works, but let's take a step back and look at the goals that shaped our design. Our objective was to create a system that could capture noisy radio signals, transcribe and translate them in real time, and deliver that translation wirelessly, all without relying on internet access, and without sacrificing the battery life or portability. To meet those goals, we defined a set of functional requirements. Capture clean radio signals using a software-defined radio, process and translate audio instantly on the Jetson Orin Nano, communicate with a mobile device over Bluetooth, display real-time transcription through our custom mobile app, and run off-grid for at least 6 hours on a single charge.
Now let's walk through a full demo of Nightwing AI Transcribe in action. To begin, we power on the system. The Jetson Orin Nano starts up in low power mode, and the ESP32 touchscreen displays the Bluetooth connection screen. The Android app initiates a Bluetooth connection to the ESP32. Once paired, the user taps Continue to move to the transcription setup. Next, the user starts the transcription process. The ESP32 sends a wake signal to the Jetson, which exits low power mode and prepares to run the GNU radio script. The user also enters the starting battery percentage so the system can estimate battery life using current sensors. Once everything is initialized, the Jetson processes incoming radio signals. Our SDR captures the audio, and the Jetson runs a real-time transcription and translation pipeline using Whisper AI. Transcriptions are displayed on the Android device with optional overlays showing confidence levels, detected language, and system latency.
This is a test in English. Esto es una prueba en español.
When the user is done, they press stop. A confirmation screen prevents accidental touches inside the backpack. Once confirmed, the Jetson shuts down the GNU radio script and returns to low power mode. On the app side, the user can choose to save the session's transcription or return home. Pressing home clears the session data, while end transcription gives the option to preserve everything from that session. From SDR signal capture to live mobile transcription, Nightwing AI Transcribe is built for portability, accuracy, and secure offline use, with every piece of the system working in sync. We have three main engineering specifications that need to be satisfied, which are highlighted in yellow. Our main engineering specifications we will be demonstrating are the latency of translation and transcribing being less than 5 seconds, for the accuracy to be greater than 60%, and for the Bluetooth connectivity to have a range of at least 25 feet from the computing device to the handheld device. We are going to demonstrate these three main engineering specifications by running 10 tests for each, collecting the data and demonstrating 3 tests in action. First, we will demonstrate the latency to be less than 5 seconds.
Testing 1, 2, 3. Can you hear me? Testing 1, 2, 3. Can you hear me? Testing 1, 2, 3. Can you hear me? Prueba 1, 2, 3. ¿Me escuchas? Prueba 1, 2, 3. ¿Me escuchas? Prueba 1, 2, 3. ¿Me escuchas?
Second, we will be demonstrating the accuracy.
Frequency is set to 146.52 megahertz. Probando 1, 2, 3. ¿Me escuchas? The quick brown fox jumps over the lazy dog.
Lastly, we are going to demonstrate the range of Bluetooth. Like any complex engineering project, Nightwing AI Transcribe came with its fair share of hardware and software challenges.
We ran into some classic mistakes, like choosing the wrong antenna early on and accidentally frying one of our current sensors during testing.
On the software side, one of our biggest pivots came after feedback from our sponsor. Originally, we designed the system to keep latency under 1 second, but after showing them different model sizes and their effects on accuracy, they encouraged us to prioritize performance, even if it meant increasing latency slightly. That conversation changed our benchmark to a more realistic 5-second upper limit, giving us room to use a more accurate whisper model. Through testing, we learned that small mistakes like leaving the Jetson in an infinite low power loop can cost you hours of debugging or even force a full OS reflash. We also learned the importance of slowing down when working with electrical systems. One missed wired pin or a missed voltage reading can take out our hardware.
These challenges pushed us to be more thorough, flexible, and better at debugging, all lessons that we will carry on into our future as engineers.
Looking ahead, we plan to expand support for multiple languages, enable multi-channel reception and transmission, and explore AI-driven speaker recognition. We're also interested in deepfake voice emulation for covert scenarios and giving users more control through language settings and offline data storage in the mobile app.
We'd like to sincerely thank our professors, faculty reviewers, and our sponsor Nightwing for their help and guidance throughout this project. We'd especially like to thank Dr. Arthur Weeks and Bayardo Payan. We could not have done this without you guys.
This experience challenged us across every layer of engineering, and we're really proud of what we accomplished. Thank you for watching.